We're going to look now at finding the area of quadrilaterals. Now remember, quadrilateral means the area of a four-sided shape, and we're going to look at four different kinds of quadrilateral. So I'm going to look at the area of a parallelogram, a rhombus, a kite, and a trapezium. So the way I'm going to set out this video is I'm just going to tell you the formulas first thing. I'm going to tell you the four formulas, show you how to use them, and then I'm going to go back to the beginning and show you where those formulas come from. And you don't need to really watch that part of the video, okay? Because to my mind, it's really important to see where the formulas come from, but it's not something that's going to come up in a test necessarily. So it's not something you need to know, but I think it's good for you to know. So I'm just going to kind of add that in at the end, okay? So let's have a look at the first shape. This is a parallelogram. Remember, a parallelogram is any shape that's got two pairs of parallel sides. Now remember, I mark parallel sides with these two arrows, so that means those two are parallel, top and bottom, and I'm gonna mark the left and right with two arrows, okay? So that's telling me like the left and right aren't parallel to the top and bottom, but they're parallel to each other. The top's parallel to the bottom, the left's parallel to the right. Now you don't need to mark that in, but if you saw a shape with those marked in, you'd know it was a parallelogram, okay? So the formula for a parallelogram is area equals base times height, where the base is this number across the bottom and the height is at right angles to that. It's not the slanting sides, it's at right angles. So for this one, base is 5 times by 3, which is 15 centimeters squared. Remember, if the lengths in the question are in centimeters, my units in the answer for an area are going to be that squared, centimeters squared. Okay? A rhombus is any shape where all the four sides are the same length. Now, how that would be marked on in a picture is they'd all have the same dash going through them. Okay? That shows you that these four sides are all the same length. So the formula to find the area of this rhombus is area is half of d1 times d2, where d1 and d2, they're the diagonals, okay? So that's your 4 millimeters and 8 millimeters here, d1 and d2, okay? So I always like to write half of, and then in here we're going to have 4 times 8. d1 times d2. Okay, now remember when we're finding a half of something, I know there's brackets there, but you could do 4 times 8 is 32 and then half it, or you could have the 4 is 2 times by 8, or you could have the 8 and times it by 4. As long as you're halving just one thing, okay, it's going to be fine. So let's do half of 32, okay, and set out a sum, just in case you need to do that. So how many 2's go into 3? 1, with 1 left over. How many 2's go into 12? 6. Okay, so it's going to be 16 millimeters squared. Remember the length's millimeters, so your area is going to be millimeters squared. Okay, and let's just check that it would have worked out okay. So if I did a half times 4, half of 4 is 2, times it by 8, that's 16. And if I'd done a half of 8, that's 4. I'd have had 4 times 4, that's 16 as well, so it would have worked out either way. So remember just to half one thing when you've got a half of. A kite is any shape where you've got like your opposite sides the same length. So these two top sides are the same length and the two bottom sides are the same length. Okay, you can also have for this, you can have a kite that looks like that, okay, where imagine it's symmetrical and not really badly drawn, where these two are the same and the top two are the same. Okay, so you can have different looking kites. And it's the same formula as a rhombus, half of diagonal 1 times diagonal 2. So here we've got diagonal 1's 4 meters and diagonal 2's 7 meters. Okay, and the same goes, we're going to have half of, and it's 4 times 7. Okay, so I could do half of 4 is 2, times it by 7, that's 14. That's maybe the easiest way. And here it's in meters squared, okay? I could have done 4 times 7 is 28 and then halved it for 14. I could have even done a half of 7 is 3.5, times it by 4 and get 14, okay? As long as you're just halving once, don't half the 4 and half the 7, because that's really quartering, okay? Last one is the area of a trapezium. Now, a trapezium is any shape with one pair of parallel sides. And remember, I'm marking that things are parallel with these arrows. So here the top and bottom are parallel. Okay, you don't need to put these markings into the picture. I'm just putting them in to kind of explain what a trapezium is. Now this one's got the trickiest formula. Okay, so it's a half h times a plus b, where h is this height that's at right angles to the top and the bottom. A and b are just the top and the bottom. Okay, so here I'm going to have a half of 3 times, and in the bracket here I've got 4 plus 10. Okay, so I've got half of 3 times 14. Now maybe the easiest thing to do is half the 14 for 7. And I've got 3 times 7 is 21. Remember as well, if you're ever going to put this into a calculator, you put half into a calculator as 0.5. So you'd have 0.5 times 3 times 14. Okay, and remember your units, centimetres squared. If this length's in centimetres, your area's in centimetres squared. Okay, so that's how to find the areas of these 4 shapes, and that'll kind of keep you safe in any test. But just, I said I'd show you where all the formulas came from. So let's do that now. So see, for this top one, the trapezium, imagine I'm going to take a pair of scissors. Oops, what happened there? I'm going to take a pair of scissors and I'm going to snip off this end. Okay, I'm going to cut that bit off. Okay, and I'm going to get my sellotape and I'm going to stick it on this end. And it's going to match perfectly because these 2 sides are parallel, they've got the same angle. And now when we have a look at the shape that we've got, we can see that it's a rectangle, okay? And the area of a rectangle is just L times B, okay? And you can see it's going to be 5 across. These are all right angles now, so these are all 3s as well, so that's 3 centimetres there, 5 centimetres on the bottom. That's where these 2 are coming from. It's still the area, the length of the base, times that red height at right angles. Okay, so that's where the formula comes from for a parallelogram. For a rhombus, imagine they all kind of come from rectangles. Imagine I was going to draw a rectangle around the outside of this. Oh, and I'm kind of going off the side of the box. Let me just move this box a little bit. Can I do that? No, maybe not. Oops. So imagine I've got this rectangle drawn around the side here. Now see how these diagonals are. This bit is the exact same as this bit, and this bit is the exact same as this bit, and this bit, I'm going to mark it with stars, is the exact same as this bit. Okay, and this bit with crosses is the exact same as this bit. Okay, so altogether the area of the rhombus in the middle is half of the area of the whole shape. Now that rectangle has got a height that's the same as this diagonal one and a breadth that's the same as this diagonal two, so you're just halving your length times breadth, diagonal 1 times diagonal 2. Okay, for a kite it's the exact same thing. I'm going to draw a box around this one. Okay, there we go, and this top right corner is the exact same as this one. This bottom right corner is the exact same as this. This bottom left bit is the same as here. This top left bit is the exact same as here. So again, it's half of this box, and it's again diagonal 1 by diagonal 2, length times breadth. Okay, so I'm just halving that. The trickiest one to explain where it comes from, but it's not too bad, is the trapezium. So imagine, here I've got half the height, okay? So imagine I'm going to cut this in half along the height. Okay, so this is now half the height. Okay, and I'm going to do a bit more cutting. I'm going to cut this bit here, And I'm going to cut this bit here. I'm going to cut them off. And I'm going to spin them round, and I'm going to stick that bit on there. Okay, and I'm going to spin this bit round, and I'm going to stick it on there. Okay, and now look, I've got two rectangles. Okay, this bottom one is B from side to side, 10 centimeters, and the height up and down is half the height. Okay, and what if I move this now? You can see I've got a box on the top, and that's A times half the height. Okay, what if I just put them together? Okay, so I'm going to put the one that's A times half the height, and I'm going to put the one that's B times half the height, and I'm going to stick them together. So I'm just moving this top box, sticking it down there. Okay, now I've got a rectangle, and the length and breadth are half the height, and this length along the bottom is A plus B. So that's where that formula comes from.